YouTube, and you can access the recorded section from our MTTS Kerala YouTube channel. I would also like to request all the participants to kindly mute their microphones throughout the session. And if you have got any doubts or queries, you can post it in the chat box or you can ask in person during the Q&A session. So please ensure that you fill the feedback form provided at the end of the session in order to receive your certificate of participation. So now without any further delay, let's begin the session. So first of all, I would like to welcome Professor B.S. Manoj, Sir, IEEE IIST Student Branch Counselor for the welcome address.
Yeah, thank you. Thank you, Grishma, for inviting me. Good morning, good afternoon, good evening, on the case of talk where you are from. Let me get into my task today. I'm really glad to be here, welcoming you all for this particular L4 talk, learn from legends and learn from leaders. So first of all, I would like to welcome Dr. Sudhakar Rao, IEEE Life Fellow, Fellow IET, and Director Northrop Grumman Space Systems. We are very glad to welcome you and very blessed to hear from you, Dr. Sudhakar Rao. This particular L4 talk is actually the treat of the year because we are going to hear from the past experiences of a legend in space antennas and space-based as well as satellite-based antenna systems. We are really glad to hear from you, Dr. Sudhakar Rao. So I welcome you for this particular event. Next, I would like to welcome Professor Andy Su from University of Dublin, Ireland, who is the chair of IEEE Future Directions Committee on LEO satellites. This particular event is very relevant for your committee's activities and IEEE Kerala section MTTS as well as APS. Really glad to receive your sponsorship and we would like to welcome you to this particular event. Professor Javed Siddiqui, I welcome you. You are a mentor to all our activity today. Professor K.R. Subhashini, who is a chair of WAMS. WAMS is actually getting founded this year as one of the notable conferences in this particular area. Then I have seen many of the dignitaries here. I could not recollect every one of you, but Dr. Nukula Srinivas Rao from IEEE Hyderabad section, Professor Mahadevan, IEEE Bangalore section. We welcome you both as members from sister sections to this particular event. And we also have seen other, IIIT Jabalpur members from that IEEE student branch chapter. So in addition, I would like to welcome all the dignitaries that I could not recollect or I could not recognize from this 200 strong participant list. Is one of the very notable and successful events that we are going to have today. So I would like to welcome the IEEE MTTS Kerala chapter, IEEE APS Kerala chapter members, IEEE IIST Student Branch chapter, IEEE GEC Barton Hill Student Branch chapter members, and the real brain behind this event, Dr. Chinmay Saha. I would like to take the privilege to welcome you to this event. Dr. Anu Mohammed, Dr. Debrade Ganguly, I welcome you for this particular really precious event. So all other IEEE members, all other members of the audience, we very warmly extend the welcome to this particular event. Thank you. Over to you, Grishma.
Okay, thank you, sir. And now I would like to invite Dr. Chinmay Saha, sir, Chairperson of IEEE MTTS Kerala chapter, to brief about our MTTS Kerala session and also the L4 series. Over to you, sir.
Yeah, thank you, Grishma. Good morning to speakers and my friends from abroad and the western part, and good evening to all my dear friends, colleagues, students, and dear participants. You know, when you have a speaker like Dr. Rao, in the podium, we shouldn't talk much, but still I'll just touch on a few points because this is a big opportunity for me also. I have talked on this type of events, on several other occasions. So just to talk about few points. One is our IEEE Kerala section, another is our IEEE societies, MTTS and APS, of course, and about the other one is the L4 initiative. So the IEEE Kerala section, if you see the history, it is one of the largest section. We are always within the top 10, and right now we are at the very top of the IEEE section. So we are the largest section right now, almost around 10,000 members. And we have, we started our journey in Kerala section as a subsection under Bangalore, but it has gone strength to strength, and now we have so many society chapters. And the entity we belong to, that is the antenna propagation and micro theory and techniques, both of these chapters are relatively new. APS started its journey in 2014 with initiative taken by Professor Mohanan and his group, Professor Anandan, Dr. Abdullah, and other colleagues at Cochin University of Science and Technology, and we are also the founding members. In last few years, we have been blessed by society leaders, different kind of support, and we have emerged at the best chapter award in 2018, and MTTS Kerala, which started just in 2019, with a lot of support from society section as well as my dear colleagues and students, we have gone strength to strength, and MTTS Kerala has achieved quite a lot. And during the pandemic, when entire globe was going to in lockdown mode, especially in India, the education initiative was also getting stuck. We thought we should do for the community whatever we can do to combat against this pandemic. So we initiated some kind of virtual events in the webinar mode. And then after a few events, we thought that we need to have some speakers who can really cater to the students, different spectrum of the students, UG, PG, PhD. And we decided to come up with an event where the seasoned speakers, the experienced speakers who have contributed immensely, technically as well as an administrative front, we should bring them in a separate podium. So this L4 is basically a brainchild of that kind of thought process that we had, and now it has become a success. It got inaugurated last year around September, October, and the MTTS president, Dr. Ala, and other committee members himself and herself were present. That was a big success, and the report of the event got published in IEEE Microwave magazine. Not only that, I am very proud to say that thanks to all my predecessors and all my colleagues and the students, we have a very active APS chapter also. And this event is co-sponsored by APS IIST and APS GC Barton Hill. I'm very happy to mention that today's event is being co-sponsored technically by IETE, Institute of Electrical and Telecommunication Engineers, India, and they have published this particular event in their proceedings, in their newsletter. And also, the event is co-sponsored by IEEE Future Direction Committee of LEOS, Professor Andin, who is present over here. So I won't take much time. I just sincerely hope that all of you will be benefited from today's talk, and you will definitely get some ideas regarding your research, your journey, your education, and you will have a very successful, inspiration from today's talk by the legendary speaker, Dr. Rao. I hope you will use this opportunity and you will get some kind of new impetus and new energy in your research journey. With this, I conclude. Thank you very much again. Over to Grishma.
Thank you, sir. So now I would like to welcome Dr. Anding Siu from IEEE Future Direction Committee on Low Earth Orbit Satellites and Systems, University of Dublin, Ireland. Over to you, sir.
Thank you. Sorry, I already said earlier on, I don't need to repeat. I think that, yeah, Zero Satellite, again, this is a small project. It's funded by IEEE Future Directions Committee. We just started 2 months ago. We organized those, try to coordinate, kind of promote the activities related to the space education. And so this is the first lecture event that we organize now. For the webinar style, we're going to organize more event later and next day, so we will welcome all to participate from us. Thank you very much.
Okay, now I kindly request Dr. Subhashini ma'am from NIT Rourkela to chair the session.
Thank you, Grishma. Good evening, all. First of all, I would like to thank you, Chinmay Saha sir, for giving me this opportunity, and welcome you all to this L4 series session. So tonight, this task of introducing our guest of honor and speaker is a great privilege. Our guest of honor and speaker, Dr. Sudhakar Rao, is an icon in the antenna community. So I would like to read a very brief biography of Dr. Rao. Dr. Sudhakar Rao is currently working as the Senior Technical Fellow at Northrop Grumman Space Systems, providing technical leadership for all divisions of Northrop Grumman in the areas of antennas and payload development for various key programs, proposals, and IRAD. Dr. Rao received B.Tech from REC Warangal, M.Tech from IIT Kharagpur, and PhD from IIT Madras. He worked at ECIL Hyderabad, LRDE Bangalore, was the postdoctoral fellow at the University of Trondheim, Norway, and then worked as a research associate at University of Manitoba, Canada during 1982 and 83. Over the past 38 years, he worked at Spar Aerospace Limited, Canada, Boeing Satellite Systems, Lockheed Martin, and now at Northrop Grumman, and contributed to antenna and payloads for more than 85 different satellites. His work on development of radiation templates for complex satellite antenna patterns for interference analysis was adopted and recommended by the International Telecommunication Union in 1992 as the worldwide standard for satellite manufacturers and operators. He authored over 220 technical papers and was awarded with 56 patents, which includes 51 US patents and 5 European, and also 5 trade secrets. His fundamental work on the design of multiple beam antennas in 1999 has been used by the satellite industry worldwide. He authored and co-edited 3 textbook volumes on Handbook of Reflector Antennas and Feed Systems, and that were published in June 2013 by the Arctic House. Dr. Rao is an IEEE Life Fellow and a Fellow of IET. He received several awards, including the IEEE Benjamin Franklin Key Award in 2006, Delaware Valley Engineer of the Year in 2008, Asian American Engineer of the Year Award in 2008, IEEE Judith Resnick Technical Award in 2009 for pioneering work in aerospace engineering, Boeing Special Invention Awards in 2001 and 2002, Lockheed Martin President Award in 2005, 7, 8, and 9, IEEE Region 6 Outstanding Engineer Awards for 2017 and 2017 Northrop Grumman's President Award for innovations and contributions to key programs. He received Distinguished Alumni Professional Achievement Award from his alma mater NIT Warangal in 2016 and IIT's Professor S.N. Mitra Memorial Award in 2016. Recently, he received the 2020 IIT's Biman Behari Sen Award Memorial Award. Dr. Rao served as the Distinguished Lecturer for the IEEE APS and an ADCOM member of the IEEE APS. He was the founder and chair for the IEEE APS Industry Initiatives Committee during 2011 to 2015, IEEE APS Fellow Evaluation Committee member during 2015 and 2017, Associate Editor for the IEEE Transaction and Antennas Propagation, and Associate Editor for IEEE AWPL also. He is the Executive Committee member of the INCAP series of conferences in India. Dr. Rao delivered, invited, and keynote talks for more than 50 conferences worldwide. Recently, he he was appointed by the IEEE Board of Directors to serve as the IEEE Fellow Committee member for 2020 and 2021 and is a member of IEEE Fellow Strategic Planning Subcommittees for 2021. He instituted IETE Dr. Sudhakar Rao Award in 2020 to recognize and honor outstanding antenna engineers. Dr. Sudhakar Rao, it's a privilege to welcome you, sir. And it's a very brief biography I have given. Thank you, sir. So over to you, sir.
Is it
Sudhakar,
my
sir?
turn now?
Yes, sir. You're audible, sir.
Perfect.
I thought Chinmay is going to present something.
Yeah,
No?
that will be there after the technical talk.
Oh, okay.
Yeah, yeah.
Thank you, sir, to be here.
Yeah, I'll not disclose further because let it be like a surprise.
Can you guys see my screen?
Yeah.
Yes, sir. Yes, sir.
It's loading, sir.
Oh, thank you, Professor Chinmay Saha, for your kind and colorful introduction. So I was hesitant to speak on this topic because this is a very loaded topic on living legends and living leaders. So when he asked me last year, I sort of said no. And then he continued his persistence and finally made me agree to do this this year. So I'm glad I agreed. So it's always my pleasure to talk to IEEE, especially Kerala section, because that's very vibrant section. And as Chinmay said, that it is the second largest section in the IEEE section in the world, all due to volunteers like Chinmay and Manoj and a
Not
lot
second
of.
largest. Now we are the largest.
Oh, you're the largest?
Yeah.
Wow, keep going. So what is
Yes.
next?
I think Santa Clara, maybe. Yeah. Santa
Who
Clara.
is the second? Is it Beijing?
No, Beijing is in third or fourth position. I think it is Santa Clara.
Santa Clara. Okay.
Yeah.
So I also like to thank all the IEEE Trivandrum IIST student branch volunteers, Grishma and Elizabeth, for designing the logo and pamphlet and also helping with the organization of the event. So my talk is recent developments of advanced antennas for space and ground application. That I'll talk at the end. But initially, I would like to talk about L4, papers and patents, and a bit reflection on my career. So the agenda is Living Legends and Living Leaders, L4, which is the main theme of this series of talks. And then I'll talk briefly about how to publish in IEEE journals. Might be useful to many of the young researchers and students. Invention, disclosures and patents. And my career reflections briefly. Recent development of advanced antennas for space, air and ground applications. So I didn't add anything on LEO, but I think I can mention those during my talk as well. So want to say that antenna engineering is an exciting field and with a lot of scope for innovation. So even today I get excited when I go to work in the morning. So I go with a lot of energy and want to do something better. So it's always exciting because there is a lot of scope for development, innovation, and developing new products for different applications. So that makes antenna field the most exciting field, I believe, in electrical engineering. So legends and leaders. I think we all know the legends and leaders of India. So and also internationally. So legend means it's not used very often. Legend means it's a rare commodity, originated from Latin legendus. So legend means something which ought to be read. So if a legend writes something, you have to read. So that's how important it is. Leader means the person who leads or commands a group, organization, or country. So it's an influential figure. So I just want to say that antenna engineers, researchers can be grouped into two categories. Academic, so main purpose is to research, teach, and consultancy. So their main interest is or motivation is to publish papers. So whereas in industry, it is basically to develop the product. Basically engineering the product for specific applications, whether it's wireless or satellite or ground or anything else. So main focus is on hardware and patents. So professional growth for both academic and industries, I think when you start your career, you will be a mentee. So you have to do a lot of reading and a lot of work for self-growth. And then you work with a mentor. So that helps a lot because you can learn very quickly. You can shadow the mentor and then learn all the tricks of the trades, and you can later become a leader. So without that, I think it's a long process. You can still do that, but I would say that it will be a long process. So I have a mentor in my career in Spar Aerospace. So I shadowed him every day, like almost 2 years. And then after that, I became a group leader as well as group supervisor. So then actually what happened was then my my mentor started working in my group. So that was, and it was a nice, friendly sort of, so he has been my good friend for a long time. Even now we talk about, he retired, of course. So classification of engineers, you can say average, good, very good, excellent, and outstanding. So leaders and legends are by definition have to be outstanding. So nothing short of outstanding, I think, work you have to do to become. So dedication and hard work needed to become an outstanding engineer. So you always have to aim for the top. So don't be a good engineer or very good engineer or excellent engineer. Try to be outstanding. So this is, we all know about epics of Mahabharata, Indian epic. So these are the legends, I call it. This is my personal opinion. So Arjuna is on the top left, is a legend and leader. Krishna, of course, is legend and leader. Then on the right is Bhima, who is legend and leader as well. And on the bottom left side is Yudhishthira, who is a legend and leader as well. And in the middle is Duryodhana, who is a leader, is not a legend. And on the bottom right is Bhishma, who is a really legend and leader as well. So these we can always relate, and we can see the quality of the people whom we call them legends and leaders. So L4 in APS. So legends and living legends. So legends are Professor Krauss, Leopold Felsen, Ramsey, who who sort of authored the reaction concept. Professor Koimjian, who is a father figure for GTD. Then the last two are actually, I worked with them. Dr. Rosen, who is Harold Rosen, I worked at Hughes Boeing, and I worked with him on a couple of programs, learned a lot. Dr. Alan Love is actually father of GPS. He's invented all the GPS antennas. That was in 1970s when there's no software is available. So, and living legends, I would consider Professor Harrington as the top living legend. Professor Prabhakar Pathak, Professor Posar, and Raj Mitra. Leaders and living leaders, I think Professor Persimmon Kildall, I worked with him a couple of years in Norway. Great leader and Professor Claricoats from Queen Mary College in UK, Professor Ben Monk, who is the father of FSS, who invented FSS, and many other from Ohio State University. And living leaders are Professor Balanis. I think we all know about Professor Balanis, Professor Lakshafai, Ramatsami, John Volakis, and Stefano Masi from Europe. Quality of leader. So you have to lead by example. So you shouldn't be afraid to fail. So sometimes I think you fail, but you shouldn't be afraid to fail. So when you try to do something out of the box, of course, there is some risk there. So you should take the risk, get things done. So you have to, as a leader, you have to get things done. Sometimes in the industry, the schedule is tight. So if you don't deliver in time, I think satellite cannot wait. The launch cannot wait. So you have to postpone the launch, and it costs a lot. And you have to be persistent. So if you're in a project and you have to think about it almost 24 hours a day. So this is an example I always give, a good example of a leader from the industry, Dr. Nazir Chahat from JPL. He's only 34 years old, but at this young age, I haven't seen anybody that contributed so much to the antenna technology. So he has already more than 100 papers, he has 9 patents, and he's the leading figure in NASA. I think his recent success is Mars Endurance and Mars rover, I think, has designed all not only the antennas, he's in charge of the communication link as well. So I think if youngsters, I think you should sort of aim to become, maybe follow him, his footsteps, and see what you can do and contribute. So L4 in APS India. So it's mainly for Antennas and Propagation Society. So legends and living legends. I think legends are Professor M.S. Narasimhan, who was my PhD advisor. So he's the person who has almost in A.W. Love's book on horn antennas. He has 7 papers included in his book. So it's a compilation of significant papers on horn antennas. So he, B.N. Das, of course, from IIT Kharagpur, he was my advisor during my master's, and he's my mentor as well. So because of him, actually, I'm here. Otherwise, I would be in Hyderabad at ECL working as an engineer. So he's the guy who basically mentored me and also advised me to go and do PhD with the Professor Narasimhan. Govind Swarup, who passed away recently. Living legend, I think Professor P.K. Saha, I think, has not written many papers, but whatever he wrote, they are very iconic papers. I think he wrote with Professor Claricoats on corrugated horns. Leaders and living leaders, I would consider Professor G.S. Sanyal as a leader, because he's the person who established the Radar Center at IIT Kharagpur and also became the director of IIT Kharagpur. Dr. Shania of LRDE. And living leaders are Dr. Satish Reddy, who is a Secretary for Defense, Professor Dr. Christopher, who also, after I graduated from IIT Madras, he worked with Professor Narasimhan, Dr. Surendra Pal, and Rajiv Jyoti. So this is a thing about advice from an antenna. This is actually Kathy Melde published this in one of the IEEE magazines. Advice from an antenna: look radiant. So always smile and look radiant. Don't be sad. Keep a low profile. Don't be too sort of boast yourself, but keep a low profile. Be a ray of light. Take time to reflect. Resonate with others. So working with others is very important. So resonate with them. Stay focused. Whatever you're working, I think you have to be focused. So there is nothing better than a perfect match, either in life or in professional work. So you always look for a perfect match. So now I'll talk about the next chapter, my experience about becoming a leader. So I don't consider myself a leader or legend, but I think I can talk about it. Becoming a leader in industry is more difficult. So need to have many skills, not just in one area. So you have to be both good in technical and management. You need both skills. So research, you need to have hardware experience. That is utmost important. Systems qualification, how you qualify the hardware, test methods. So engineering the products, competitive analysis, latest developments. So you have to look into patents, papers. There are always the smart people around the world. So always you learn from them. So you have to keep studying. So you have to work with vendors or subcontractors. You have to work with customers. You have to write the proposals. So you have to prepare the presentations. So all these skills you need to have if you want to become a leader in the industry. And also mentoring, and you have to work with compassion. So mentoring is very important because all the companies now, they sort of ask the senior people to mentor the young engineers. So hard work and perseverance is also very important. So you need to have national and international recognition. So at the end, I think leader is a recognition from peers, not from what you think. It's the peers have to say that you're a leader or not. So now I talk about publishing. I think I presented this sometime back, maybe in another venue. So this is mainly for students and researchers. So you can publish in conferences and journals. Both are important. Conferences, we have APS RC conference. So now I think this year it's in Singapore. I think it's going to be in hybrid mode. So Indian conferences on antennas and propagation in CAP. Now we have AMS as well. So APCAP, ISAP, UCAP, all are good conferences. So if you want to publish in journals, I would recommend actually AP Transactions on Antennas and Propagation, Antennas and Propagation magazine. So I prefer, I actually read a lot, people in the industry lot the magazine a lot compared to CAP. So IEEE AWPL, IETE, now called IET, Proceedings IEEE. So conference publication is important too, also important because you need to network with others, go to conference and see what people are doing. So journal publications gets, of course, professional recognition. So what I say is the quality is more important than quantity. So even if you have one or two good papers, that's enough. So you don't need to have hundreds of papers. So example is Professor P.K. Saha has like 2 papers on corrugated horns, and he is famous for that. So quality is more important than quantity. So don't publish anything average. I think work on it for a while and try to improve the quality. How to publish? So like I said, don't rush your publication. Prepare well. Do the literature search, see what people have done related to your subject. You have to identify the novelty. So basically what your paper adds to literature, that you have to. Can you please mute your microphones? Okay, keep it short and sweet. So people try to write long papers, so I don't recommend that. I think you can convey your ideas in a short paper. So try to keep it like 5-6 pages. Figures and tables are important because they convey the message. So picture is worth 1,000 words. So just imagine, prepare a good quality figures and tables. You don't need to write too much. Short, well-written papers have good chance of publications. So sometimes I think English is important. I think you don't want to upset the reviewers. So check your grammar, writing style, and if you're not familiar with English that much, get somebody who is good in English review your paper. So basically you have to revise, and you have to be your own critic. So if you're satisfied, then you can submit the paper. Contents, title, abstract. So title is important because don't write long titles, just convey with a short few words. I think you have to convey the title of your presentation. Abstract. Include the novelty in the abstract, what your paper is about. Introduction, so importance of your work, applications, prior work, extension, new work presented in the paper. So main sections, keep them 3 to 4, design, analysis, fabrication and test, comparison of results, etc. Summary and conclusions and acknowledgements and references. So this I put my paper because not because it's my paper. Actually, this paper got a lot of feedback from people from the industry. It was published in AP Magazine and last year. So Colin Ostrud is an intern from UCLA who worked with me for 2 summer terms, and he actually did most of the work. I just gave him some guidelines, and so I think if you have time, go and read that paper because other people consider it a very good contribution. So, submission and review process. So use IEEE double column format. So keep it 7 pages or less. So don't try to, I would say that don't go beyond 6 pages. So longer papers take more time and it's unnecessary as well. Give chance to others because 1 page of publication costs a lot for IEEE. Once you submit, editor in charge will allocate papers to associate editors. So that takes about a week. Then AE assigns the paper to 3 to 4 reviewers. So that's about 2 weeks. So reviewers take about, given about 4 weeks time to submit their reports. 4 weeks for TAP, but AWPL is a fast-paced publication. So generally we give 2 weeks. So categories are accept, minor revision, major revision, reject, and some have reject and resubmit as well. So minimum 2 reviews are required. So if the reviewers are not consistent, then AE will send to the 3rd reviewer. So that's about 2 weeks. So then AE summarizes and makes recommendation to EIC, editor in charge, editor in chief. So sometimes TAE as well. So that's about 1 week. Then EIC makes a final recommendation and sends letter to the corresponding authors. So it takes about 4 months to get your first response on your paper. Then you have to go through revisions and final decisions based on the recommendations from the EIC. So typically it goes to the same reviewer. So try to answer all the questions properly and explain the differences between what reviewer said and what you think. Sometimes you have to agree with them and revise your paper accordingly. First submission is important. So that basically avoids more revisions. So try to edit as much as possible when you submit the paper. First paper publication is always precious for any author. So you get really excited when your first paper is published in IEEE journals. So motivates you to write more. So be careful not to overpublish as well. So sometimes overpublishing is not good. A good paper with a lot of citations is worth more than 10 average papers, I would say. So a lot of competitions to publish. So some country pay heavily for authors with if they publish in IEEE. So they, because of that, they try to submit more and more papers, which may or may not be a good idea. So, but do good work, prepare well, and good luck with your future publications. So now I talk about innovations briefly. So innovation is the process of translating an idea or invention into goods or services that create value or for which customer will pay. So for an innovation, the idea must have some economic impact, otherwise, or it has to cater for a specific need. So that's basically the innovation. So IEEE mission statement itself puts innovation as in the mission statement itself. IEEE IEEE's core purpose is to foster technological innovation and excellence for the benefit of humanity. So you can see how important innovation is. What is innovation? So it's not an imitation. It's not a minor improvement over prior inventions. So this is basically out-of-box idea or concept resulting in a product, concept, or method. A new idea, creative thought, new imagination in form of device or method. Invention is the result of innovation. So you innovate and then you submit for invention. Inventions are often protected by patents or trade secrets. For example, US Patent and Trademark Office. Similar thing you have in India and other countries as well, Europe, etc. Innovation typically happens by necessity. Sometimes you have to develop a new product. Sometimes it happens by accident. You have some idea in mind while you're relaxing or sleeping in the night, and then I think you might get an idea, and then you work on it, and it becomes an innovation. So other one is planning. Sometimes you plan for the innovation. And product of innovation is an improved product, a patent, or a trademark. So we all have innovative minds. Only thing is we have to channel our thoughts properly. We have to focus a bit. And if you do that, I think everybody can invent. So why innovate? So companies put a lot of innovation or patents are very important for the companies because they get royalties. So it also have advanced technology or products like iPhone, GPS, etc. So you get a professional satisfaction if you get a patent. So it's engineering pride. You can consider yourself worth the patent. So that means you have done a good work. So it has monetary benefits as well. So passion and personal satisfaction, passion, I think. So personal satisfaction is most important. I think forget about the monetary benefits. You get monetary benefits, but that's not what a lot of engineers work for. I think you get more personal satisfaction. So this is engineers innovate and researchers publish. So it depends on if you're an academician, I think you want to publish. If you're a professional engineer, you want to innovate. So patent versus paper, I think I already talked about. It's basically science versus engineering. So both are important. So I would say a patent is worth several publications and more. So because you get some monetary benefit as well. How to innovate and obtain a patent. So innovation requires understanding of requirements and focus on key requirements, not all the requirements, but focus on key requirements. Knowledge of prior art. So you have to read a lot. All the inventions or patents published in USPTO or European Patent Search you can do and see what people have done. So that way you can learn what is current and what people are working on. So you need to have analytical mind. You need to have software knowledge. Hardware knowledge is most important because you have to make a product at the end. So it's multidisciplinary areas, like you need to have RF, mechanical, manufacturing, systems and tests, etc. So novelty is very important. So unless it's novel, you won't be given. If something is similar, a patent is awarded before, then you won't get the patent go through. So hard work, I think issued patents comes once a week on Tuesday. So USPTO publishes them. So if you look into the antenna field, you get about maybe 350 to 400 patents every week. So out of that, maybe 10 or 20 are relevant to you. So I think you have to go through them, see what people have done. And applications, that is before the patent is issued, it's application, patent application it's called. So they'll publish every Thursday. So you can also read that, spend some time. So patent is an outcome of innovation process. So you have to complete the work first and think of patenting or not later. So don't think of start the work with the idea of patent, and I think the completing the work is more important. Procedure, I think USPTO, you can read, and EPO, that is European Patent Office, World Invention Patent Office. They're all websites I think you can go through. File an invention disclosure with your company or yourself and get approval for filing from your company. So selected disclosures, all disclosures, when you submit your idea, it's called invention disclosure to the company. So the company will review and they select only, they won't file all patents. They select only a few and then they go ahead with filing the patent because it costs a lot of money. Each patent costs about 20K. So that's filing and lawyer fee, etc. So you need to prepare a PowerPoint package and attach with the disclosure so that people reviewing your invention disclosure know what exactly your patent is. Then it will go to patent attorneys. So they will actually put your package into patent. Typically, it takes about 3 to 4 years. So whereas paper takes about less than 1 year. So it's a whole process. I think patent examiners are tough, so you have to go through them like 2 to 3 times, revise, and the claims are very important. Sometimes they may not allow all the claims, so you have to explain to them. So these are the title, abstract, background, prior art publications, etc. So you need to have a detailed description and drawings. So drawings are very important, so you have to prepare them nicely. Claims are very important, so key to the patent. So typically there are about 20 claims. Some are independent claims, some are dependent claims. So independent claims, you might have either 1 or 2 or at the most 3. So rest of them are dependent claims on independent claim. Broader claims are preferred because then you can expand to not just limited to one application, but cover several applications. So patents that are most difficult to copy are highly beneficial to companies since they bring their royalties. Other companies might want to use your patent and then they have to pay to the company royalty. So some example of, one example actually. So you get a patent plaque once your patent is issued. So this is the one on an antenna system that single design can use on multiple orbits. So this has significant cost advantage. So you don't need to specifically design for each orbit. So you can design antenna system that works over an orbital arc, and same design you can use it for different orbits. So this is authored with my colleagues Jack Bauer, who is a system engineer, who is an antenna engineer, and Bob Rink is a propagation expert. So what is novelty? So it identical antenna design for multiple orbits, satellites. So significant cost savings for fixed satellite service and broadcast satellite service. So currently it's employed over 20 satellites in US and Europe. So next topic is I was asked to give a small briefing on my career. So education, early job experience in India, postdoc research, first job in aerospace company, moved to ESA, experience with different companies, my contribution to industry and academia. So education. So this is very important because my early schooling happened in a village called Lintur in Andhra Pradesh. So used to walk because we don't have school there, so we have to walk every day 3 miles each way from my village, Elavaru to Intur. So there's no electricity, no drinking water, but life was good. We all enjoyed. Competition with my sister and cousin sister helped a lot. So they're all in the same school because I got double promotion. So my sister is, both are 2 years elder to me. but we're in the same class. So I used to read less, but active in games and interested in Telugu poetry at early age. College is REC Varangal, NIT. So then I worked at IIT Kharagpur, Masters and PhD from IIT Madras. So I represented inter-REC in basketball, one IIT Kharagpur basketball tournaments. I'm also VSL champion in caroms and table tennis. So PhD happened really by accident, thanks to my mentor, Professor B.N. Das. So I was actually, when I was working at ECL, he came to visit and then he told me, go to Professor Narasimhan, he wants a good student from IIT Kharagpur to do PhD and at the same time work as a research associate on ISRO project. So that's basically I was working on that and doing part-time PhD. So I used to work 16 hours a day. So hard work. Completed PhD in less than 2 years with a tough advisor like Professor M.S. Narasimhan. So early papers published in IEEE TAP and on application of GTD to practical antennas. So 6 papers written and submitted in 8 months. So early job career in India, worked at ECL after my MTech at IIT Kharagpur. I thought I'll get some practical experience before joining the PhD. So that helped a lot. So I used to take care of testing line-up side and tropospheric antennas. These are large reflectors. So go to the outdoor range, far field range, and do the measurements, and also tuning of C-band feeds. So learned about ranges and antenna testing early in the career, which was later helped me a lot to develop and establish world-class test ranges like compact range and plain and A-field range at SPAR, Canada during 1980s. After PhD in 79, I joined LRD Bangalore, worked on the first phase array system at Expand for airborne applications. So I was doing the analysis methods for space-fed planar arrays, phase arrays at Expand, typically collimation error computation and characterization, etc. So left LRD in 1981. So this is my professional path. Started at Hyderabad, ECL, then came to IIT Madras to do PhD, then joined LRD Bangalore there for about a year. And then all the way went to Norway to do postdoc research in University of Trondheim, Norway. From there went to University of Manitoba, Winnipeg, Canada. From there came to Montreal, worked at Spar Aerospace Limited for about 14 years. From there came to USA, joined Hughes and Boeing, which became Boeing later in Los Angeles. So after I think 7 or 8 years, I left and joined Lockheed Martin because I got saturated and I want to learn a bit more. So I took the opportunity to join Lockheed Martin and worked there about 8 years. And from there actually came back to Los Angeles to work for Northrop Grumman. So I'm now actually grounded in Los Angeles. I don't think I'll make another move from here. So this journey is over 45 years, 3 continents and 4 countries and 8 cities. So always I think I'm sort of a bit maverick, want to try new areas and new cities, new companies as well. So postdoc, I think joined University of Trondheim in 1981, got a Royal Norwegian Scientific and Research Fellowships. They gave about 20 fellowships each year covering all engineering fields. So that was most useful part of my career. So there I learned how to apply your knowledge to practical problems. So I worked with Professor John Anders and Persimmon Kildall as well. I think a lot of people know him, he's no more, on designing antennas and feed systems. So I worked on feed systems for a radio telescope in Iraq. So that was successfully installed. And also learned how to ski in the icy slopes of Norway and Sweden. So it used to be so crazy that when the ice melted away in Norway, we used to go to Sweden and ski there. So that time, actually, Professor Claricoats visited University of Trondheim, and he offered me a postdoc fellowship. At the same time, I got from Concordia and University of Manitoba. So decided to join University of Manitoba. So worked on low side lobe sandwich wire antennas, reflector antennas, feeds, and phase center analysis. So Professor Latshafai became a mentor and a long-time friend till date. So we talk once in a while. So of course his health is not keeping very good health, but he's still, I think, we are in touch. So first job in aerospace, I think while working at the University of Manitoba, I got a couple of offers. So joined Spar Aerospace Limited. So a lot of people advised me to join Canadian Communication Research Center because it's a government organization and with the job security. But I decided to take a challenge and join a private company, like Spar Aerospace. So that was best in my career. I would say that that's where most of my learning happened. So it's a small group involved with antenna designs. So we used to design our own filters, beamforming networks, manufacturing, testing, qualification, customer interactions, proposals. So there, I think I developed a high-performing team. So involved with leading a team, writing proposals, programs for a lot of customers from European customers, South American, Canadian, US as well. So that's the place where I developed templates for satellite antenna radiation patterns that was adapted by CCIR as world standard in 1992. Move to US also happened unexpectedly. So Quebec referendum, that time Quebec wants to separate from Canada. So then my daughter was just going to elementary school and they said that they have to put her in French immersion. So 5 years they teach only French and no English. Then we said, okay. That time Hughes was asking me for a couple of years to come and join them. So finally I wrote an email to the director of antenna group and he immediately surprised and told me that come tomorrow, we'll arrange a ticket. And so I went there and decided to join. So there I worked with wideband global satellite, DirecTV, and NICF2, Thuraya, a lot of programs, learned a lot. Then I joined Lockheed Martin in Newton, Pennsylvania. Worked on GPS-3, BSAT-3C, Venasat, JCSat, series of satellites, including JCSat-10. Then joined Northrop Grumman in 2010. So, and working still. So expanded scope covering not only satellites, but also not commercial satellites, but military satellites, aircrafts, and currently I'm working on ground systems as well. So this is just one slide to show the satellite antenna systems and components. So you can see on the top left, when the satellite is in space and deployed, you have 4 reflectors, 2 on each side of the spacecraft, 2 on west side of the spacecraft, 1 on the native deck. So all these actually, they're very large reflectors. Some are shaped coverages, like on the bottom shown, which provides a shaped coverage by using a single reflector and a single feed. But here the reflector surface is shaped to create this is a weighted coverage at Ku band. So this provides actually compensates for the propagation, atmospheric propagation differences within a coverage. For example, Florida gets a lot of rain, so you need to give 10 dB more gain compared to a dry area like New Mexico or Los Angeles. So you can do that all in using one antenna. So including actually Alaska and Hawaii as well. So that's key here is how much efficiency you can get and how much gain you can improve, even with a weighted coverage like this. When the satellite is about to be launched, so it has to be stored in a small volume within the fairing of the launch vehicle. So typically 3 meters or 4 meters at the most. And then the two reflectors are stowed together, like what you see on the east side and similar on the west side. And you can see the horns there. This is how the satellite will be launched in a fairing. So some, I think, antennas here, you see the phased arrays we developed for advanced EHF military satellite, so which works at 20 and 45 gigahertz. So this is the receive phased array. So that's basically the heart of the satellite because it has to adapt for any jammers or multiple jammers coming from the ground. So this has about 400 elements. You can see the heat pipes where it takes out the heat from the LNAs and other repeater equipment through, and then dumps into radiator panels. Some of the antennas, so this is the advanced EHF satellite. You see the middle of the right side. So this has about 16 antennas, 3 phased arrays, about 12 reflectors, and a couple of TT&C and global horns. On the top right, you can see the dual reflector antenna with actually displays ellipsoid. The key thing there is you don't see any struts. So the subreflector is supported by the feed cone, so you can avoid the block from the strut. So that improves the efficiency quite a bit. And on the middle, you can see the helix actually. So that is for GPS, you generally use helix. At low frequencies, helix is good because you can generate the circular polarization without the need of a polarizer. For EHF also, it's a good antenna to use. And then the TT&C you can see in the middle. So it has 2 bicons, telecommand bicon on the top and telemetry bicon on the bottom. So this provides a toroidal shaped pattern. So when the satellite is in the transfer orbit, that's the only thing you have communicating with the ground. So if you lose this one, then you lose the satellite. So that's also very important. So some horns actually C-band dual polarized covers 4 gigahertz and 6 gigahertz. Dual polarized transmit and dual polarized receive. So there are filters inside to separate, to provide isolation between TX and RX. So some of the coverages here, you can see multiple beam coverage. This is for the local channel broadcast for DirecTV 4S. So you can see the reuse with the different colors. So same color is reusing the same frequency. So that way you can get more bandwidth, effective bandwidth of the system. But the key thing here is it's a bit difficult to design these systems through because all the beams on the East Coast are narrow and provide high gain, whereas on the West Coast, the beams are big and provide lower gain to compensate for the atmospheric attenuation. So what you have to do is, since you're using the same reflector, you have to vary the feed sizes and you have to space them such that you get enough isolation between the reuse beams. So other challenges for geo satellites is thermal. So very high power going through, sometimes 5 kilowatts or power is going through the feed system. So you have to make sure it doesn't multipact. Thermal, they go through very high temperature excursions like hot and cold. So go from minus 140 degrees C to plus 170 degrees C, almost 310 degrees. So you have to design all the feed components to over a wider band to cater for the thermal range. So PIM, passive intermodulation, is important because nowadays you want to reduce the cost and use the same feed for both the TX, RX and optimize the coverage for both bands. So when you do that, I think some of the high power transmit carriers, they beat and create intermods on the receive frequency. So you need to isolate the receive quite a bit, sometimes almost 120 dB. You need isolation between, so that means your diplexers and filters get very challenging. So PIM levels, typically you keep them around minus 140 dBm. So ESD is very important because it's in vacuum, there's no atmosphere. So once you use materials like dielectrics, etc., it collects charges, and over time, I think it breaks, and then the hardware is gone. So the rule of thumb is don't use any dielectrics in space. So you have to use only metallic surfaces, either aluminum or copper or silver. Cross-pole is very important because all these satellites, they want to reuse the frequency.
Dr. Rao,
Yes,
which slide you are showing now?
28.
Okay, okay, fine. Yeah, I thought like the slide is frozen. How many more slides do you have?
Not many.
Okay, so because
Do you have
we
any
a
time
second
limit?
part, yeah, we have a second part. So if you can finish it off by next 10 minutes, that would be great.
Yeah, okay.
Okay, yeah.
So here, since it's also sponsored by Leo Sat, I thought I'll show one slide. Initially, I was not, I just included today morning. So you can see most of the satellites in the geostationary orbit, but nowadays there are a lot of interest in LEO satellites where your altitude is about 1,000 kilometers or less. MEO is up to 20,000 kilometers. Geostationary orbit we know is about 36,000 kilometers. So geostationary orbit is plus minus 8.7 degrees angle, whereas LEO is, since altitude is less, its angle could be plus minus 60 or 70 degrees depending on the altitude. So that means also you don't need that much gain because you don't have that much atmospheric attenuation because the altitude is 4 pi r over lambda square is the attenuation, right? So, but the challenge is how to make it small and at the same time able to communicate with other satellites that are trailing or going ahead through crosslinks. So crosslinks is typically done at V-band, but sometimes you do at other bands as well. So it requires three components. One is, of course, the satellite, other is the ground station, other is the launch vehicle. So all three are very important. So there are different satellite services like BSS, FSS, inter-satellite service, mobile satellite service, and personal communication satellites. So the design depends on satellite service and also the coverage. So that makes it almost, I worked on about 85 satellites, and none of the antennas are identical. So each antenna is different. So that makes it interesting. I want to show a video here to show the complexity of the antenna system. So this is, we worked with the NASA on SMAP. So we designed the reflector and the feed system was done by NASA. So you can see the complexity of the antenna. I think I showed this video before, but the black cylinder is basically the reflector. It's a 6-meter mesh reflector. You can see it starts deploying after a couple of weeks after the launch, once the solar panels are deployed. So the mesh opens, like mesh is actually made out of thin molybdenum wires, 1 million size. So it has the front mesh and back mesh to support the surface tension of the front mesh, which is important. Then you have a corrugated horn illuminating the mesh reflector. So you can see that this is in a 650 kilometers polar low Earth orbit satellite. So the antenna rotates at about 35-degree conical angle, and the spacecraft rotates in opposite direction to maintain the balance. So as it rotates, it creates a conical swath on the ground. So this is mainly to measure the moisture content of the soil near the northern poles, and also to see how the ice glaciers are depleting, I think, which is a problem nowadays. So you can see the swath actually going through. The satellite is moving across the northern hemisphere. It creates different swaths, and you can get return signals, and you can estimate how the soil moisture is, and then status of the ice glaciers. So this is just, I'll don't have much time, so I go through some of the recent developments. So this is the segmented UWB antenna. Actually, UWB antennas, generally they call it if it is more than 2:1 bandwidth. Here it is 60:1 bandwidth ratio, covering 1 gigahertz to 60 gigahertz. So this is for terrestrial RF wireless application, 6G, etc. Key requirements are lightweight, compact envelope, 24-inch by 24-inch. So beam scanned over plus minus 90 degrees using 2-axis COTS gimbal, tripod mounted and low cost. So the cost and the size and mass are key important factors apart from the bandwidth. So we know that 1 to 60 gigahertz you cannot achieve. If you use a phased array, you need the 10,000 elements and the cost is too much, and this is supposed to be low cost. So what we did is we segmented the frequency into 3 high band, medium band and low band. So gain values range from 6 dBi to 43 dBi, provides more than 100 gigabits per second capacity. So this is the design what you have. So you can see the low band is given by 2 ridge COTS horns. So one for VP, one for HP. The medium band is a high efficiency horn antenna covering 8 gigahertz to 20 gigahertz. And then the high band antenna is a ADE with a 12-inch reflector, providing higher gain up to 43 dB. So you can see the directivity versus frequency from 1 gigahertz to 60 gigahertz. So provided by the 3 antennas. And the key thing is all have to be held together, and they should be moved together through a gimbal system. So we identified a low-cost gimbal manufacturer. So we are working with them. So that gimbal costs only 5K, whereas typical gimbal costs about $1 million for space. So this is ground application. And then there's a tripod mount where you mount everything, and then soldier on the ground will be able to carry it, disassemble and assemble and carry it with him. So that's why the mass is very important. So these are the patents of the 3 antennas. So we actually finished the proposal in 2 weeks, but I think a couple of months back, customer said that we got the contract. So now we are working on finalizing the design and going ahead with the fabrication as well. So this is another PFC program where soldier has to communicate with aircrafts, has to communicate with the headquarters. They have to communicate locally through different antennas. I think soldier carries with his manpack. So again, key things are mass and cost, and also some other aspects. So there are thousands of units I think we need to deliver, but right now I think we delivered some of them, and they're under field test. So one is a pen cap, other is bunker antenna. These are omni type. And then we have 10 by 10 phased array and also quad band pedal reflector, which is a novel design. It covers 4 frequency bands and very cheap. So this is a pen cap antenna for UAV. So you can see 2 antennas, one on the bottom of the wing, other is on the top of the wing. So each antenna covers 2 pi steradians. So a combination of these 2 will provide you 4 pi steradians. So this has to be very compact, 1.2 inch by 0.8 inch or so, and mass is very low mass, 50 grams. So this is the design. So it has a radome on top. So this is the antenna with a patch with a single feed. You can see the key thing here is one is of course the gain, and also you have to minimize the backlobe radiation. So the gain, I think, and then actually return loss, you can see the solid lines are theoretical values, and the light lines are measured values. So the 2 lines are for 2 different dielectric constant, slightly varying because that's the manufacturer gave us 2 values. So we just use those 2 values computed, and all this design is done in about 2 months, and we fabricated, we completed the testing. So it is first time success. So now they're with the customer for field testing. So some of the measurements here, you can see how well it matched. I think between 6 units versus computations. And these are radiation patterns measured and computed. The dark lines are solid lines are computed. So one is on the left side is a forward direction, other is a backward direction where you need to minimize around 180 degree plus minus 20 degrees. You need to minimize the radiation. So we could do that by shaping the ground plane a bit. This is the man-packed bunker antenna, we call it K-band. So this has to provide 4 pi steradians because soldier will be carrying on his backpack. So the design is inverted F antenna. This is all metal. Then you have a radome on the top. And then there is some glue actually which attaches the radome to the metallic inverted F antenna. And mass is very low, 250 grams. And key thing here is deployment actually. When the soldier is lying on the ground, it is folded. When the soldier is standing, it is unfolded. So it has to go above the head of the soldier by about 12 inches or so to minimize the radiation on the head. And when the soldier is lying on the ground, you can see it is away from the soldier's head as well. So when it is folded, actually you have the clip here and you have the antenna on the right side top. And then the bottom side is the connector. So you can see these are two rods, actually Rexolite rods, and you have a clip. So, and you have a handle here, which you can move between the 2 stops, which are shown as a blue. And then there's a conduit actually, which connects. The cable goes inside and comes out. So when you remove the clip and then take out this, push this top rod, then it goes, and then the sleeve actually moves between the 2 stops. So it becomes like an unfolded configuration. So there are practical aspects of this. So you need to be careful in selecting the materials, etc. But this is also first time success. So we put a lot of effort in analyzing, taking into account the scattering effects of the rod and the materials, etc. So, and then the phased array. So this is a 10 by 10 phased array. And you can see the element pattern, subarray patterns. So it's 2 by 2 subarray. And then the final pattern for different tapers if you want. We have the flexibility to reduce the side lobe levels by using a taper on the subarrays. This is the quad band pedal reflector antenna. So this is the very innovative design. Again, the size has to be low, 10.2, and it should include a reflector, which is about 15 inches. And then the feed to cover all KU transmit, KU receive, K-band and Ka-band frequencies. It has to be mounted on a gimbal and mounted on a tripod. So you can see that the reflector is made out of 6 pedals. So each pedal is, you can see the size, 7.5 inch by 6.5 inch. And then you have to stack in the suitcase carried by the soldier. So you can stack them, and each one, I think we have 6, but we put actually 2 additional ones in case if something breaks, we can use the other one. So the patterns you can see 20.2 and 30 gigahertz, very high performance. So when it is installed, you can see how it looks like on the left side. So you have pedal reflector, the horn with and then there is a quadruplexer. That's a key component as well, because you need to isolate the 4 frequency bands. So then this is the vehicular antenna, mainly for the missiles. So this is the new contract we got from the government. It's a very big contract, multi-billion-dollar contract. So they want to improve the old designs of the missiles. So old designs, you can see the phase variation. The key requirements are gain over large coverage, stringent phase variation. So it used to be 20 degree per degree. Now they have reduced to 2 degree per degree. So that's where the new design has to come in. So it has to be azimutally almost uniform, both in amplitude and phase. So low mass and thermal, because the heat when the missile is launched, it goes almost 1000 degrees C. So we have to choose the materials properly. So this has both the GPS and S band, L1, L2, and S band. So we made a 2-element prototype to check the simulations first, and we got very good agreement between the measurements and simulations using CST. Top is the amplitude patterns and bottom is the phase patterns. So with that, we design a novel antenna, which is a sector, call it sector antenna. It's made out of 6 sectors assembled around the diameter of the missile. Good thing with this is there's no BFN. Each sector is end-fed, and it's a traveling wave structure with slots. But to reduce the mass, we have to use undersized waveguide here. So very thin waveguide with ridges as well to reduce the size of the waveguide. So it has other 5 slots for the sector. So there's no BFN, so amplitude is very good. So it's all metallic. We cannot use any dielectrics again because the temperature. So easy mitigation for ESD. So high thermal stability and insensitive to tolerances. So this design is almost finalized now, and we have to deliver the prototype in about 7 to 8 months, I believe. Another is an advanced ground antenna. So this is AFRL. We have a contract to develop advanced ground antennas. Typically, most of them have Ka band and S band, L and S and Ka band. So that's they have hundreds of ground antennas from 3 meters to 12 meters. So they use FSS here. So that's a frequency selective surface to spatially isolate the 2 frequency bands together. So FSS reflects the Ka band signals and transmits the L and S band low frequency signals. So since the low frequency feed at the top, you have a long cable to go through, and it's a lossy cable. So now they wanted to add 6 more additional frequency, X band, K band, and upper Ka band as well, up to EHF. So they went to the vendors, Viasat and Hughes Networks, and they said they cannot accommodate because FSS cannot isolate so many frequencies. So then they went to other suppliers as well, but finally came to us, and I think we said within a week, I think we said we can do it, and showed on the right side. So what we did is remove the FSS, remove the low band frequency on the top, and remove all the struts, which cause almost like 0.5 to 0.6 dB gain degradation. And then subreflect is supported by the feed. So feed is the heart of this system. So it has divided into 3 frequencies, aperture 1, aperture 2, aperture 3. So high frequency band is waveguide, and rest of them are nested coax. I don't want to go through, but it's very complex network, and we are finished the design last year, and we are in contract to deliver 3 feed systems to integrate with the reflector. So they can reuse the main reflector, and they modify only the feed system and the subreflector. This is the WISC-ET satellite, which has V band and W band. It's a 36-inch. So these are new frequency bands, which provides 5 gigahertz bandwidth, and also it can accommodate more. In future, you can accommodate more satellites in the geostationary arc with this frequency band, because you can reduce the spacing from 2 degrees to 1 degree or so. So this is a feed network. So wideband horn with the septum polarizer and diplexers and some test couplers. So future, this is probably the last chart. Future antenna technologies, 3D manufacturing. So we are actually doing 3D manufacturing, and we have done a KU band horn and also some components, phase arrays, just the apertures. So pedal reflector, we talked about low cost phased array. We are working on it. Mesh reflector technology at high frequencies. So typically it has 10 openings per inch at low frequencies. So we want to use 40 openings per inch and to cater for EHF, up to EHF frequencies, K band and EHF. VW bands I talked about, and integrated feed systems. So integrated feed systems are important because it's you don't design these components like horns, polarizers, OMTs, filters, diplexers, etc. Separately. You have to integrate together, analyze together, and then when you do that, I think when you do that, you design to basically perform.
ഞാൻ സംഗീക്കൊന്ന് അയച്ചനെ അതിന്റെ ഒരു ഇത് മാത്രം മോട്ടിവേഷൻ എന്നുള്ള കണ്ടിനല്ലോ അങ്ങായിട്ട്
We are getting some background noise.
Please mute yourself.
Please mute yourself.
So for these future systems, cost, mass, capacity, and schedule are key factors. Schedule is also important because sometimes you have to deliver them fast. There's no second trial, so you have to be first time success. So last one, summary and conclusion. So want to say that antenna is very exciting field to work and innovate. So each design is different. So as a student or young professional, try to understand the basics. So strong foundation is very important. And once you learn that, it's easy to apply. So in the early career, please work with a mentor. It helps to sort of give you the boost early in the career. So after that, develop concepts and out-of-box ideas when you become senior engineer. So, but you shouldn't be afraid to fail. So I think you have to work on, when you work on these out-of-box ideas, all ideas won't work, but don't fail too often. So then it's a problem. So you need to acquire critical skills. So you need to get hardware knowledge. That's, I would say, most important than software. I think a lot of people I see is run some CST, run some HFSS and design the antennas. So you can't design any antenna with software. I think you need to have, you can design these antennas very quickly, maybe in a couple of days given the requirements. You use the software sparingly only to check your, to further optimize and do the analysis. So mechanical design is important. I think you need to have some mechanical knowledge. Manufacturing is also important, how you manufacture the different components. You need to interact with systems. You need to understand what are the different things system engineering wants. You need to work with them. Customer understanding is also important. So you have to see what customer wants, what's his top priorities. So you try to cater that one. And more importantly, work with passion. It makes a big difference. So don't work because you have to work. So you work with passion every day when you go with a lot of enthusiasm to do something new. Know the industry. I think it's important to know the industry. There are smart people all around the industry. So you have to read a lot, see what they're doing, attend conferences and talk to them. Subcontractors is important. So you need to work with subcontractors sometimes. So you need to know their capabilities and what they're good at. You need to work with customers and you need to get a competitive intelligence too, because if you're working for a company, you want to know what competition is doing. So experienced engineers should be able to design antenna within few days, almost, I won't say 100%, but almost 80% of the design. Enjoy your work, that is important. If you don't enjoy, then it's not good. So innovation should be the daily routine of engineers. So keep innovating and be mad to achieve your goals and be a child to enjoy the success. So always, I think, try to set the goals and try to achieve the goals. And once you achieve the goals, enjoy the success. That's also important. So that's all I have. And I think I am slightly over, but I hope you will excuse me for that, Chinmay.
Thank you, sir. Thank you so much. That's really an amazing and wonderful journey, sir, in the satellite and antenna systems. Sir, we have a couple of questions, sir. Sir, we will take for 2 minutes, sir.
Yeah, sure.
Okay. Sir, one student asked, sir, can you give some examples in radar application where the side level suppression is required and where the side level suppression is not required?
The one I sort of showed you, the SMAP, that's also a radar. So their side lobe level is not important. But when you are working on a radar, so your side lobes are very important. So you need to lower the side lobes because you want to detect the target first. So you don't want to have very high side lobes. Sometimes the side lobe levels we have to design 35 dB or even 40 dB, especially for phased arrays, because sometimes you have to keep away from some jammers and then you need to detect your target. Most of the returns you need to get from the target. So if you have some high side lobes, you might be picking up some noise from the other sources. So satellites you need, that is for radar. Satellites you need low side lobes as well because you want to maximize the ERP and the gain, GOT as well. So if you have high side lobes, you lose the gain. So for those reasons, I think you want to really lower the side lobes. Some applications you may not have, like even ground antennas, you have to meet, not lower the side lobes because they have some side lobe template you have to meet, 29 minus 25 log theta. So that's mainly to far out side lobes you have to suppress. So.
Thank you, sir. Sir, one more question, sir. How is pen cap antenna back radiation minimized and to what extent?
Oh, no, yeah, that's a good question. I think initially it was about 10 dB just with a ground plane. But then we have to shape the ground plane such that you minimize the back radiation. So after that, I think we got about 15 dB. Spec was about 12 dB. So we could get about 15 dB by shaping the ground plane.
Yes, sir.
It's shaping is one is of course the shape. Other is we have to use some absorber material to minimize the back radiation as well. It's a coating. It's not a material, but it's a coating.
Okay, sir. Sir, one more question, sir. What are the different practical ways or techniques you have used to feed the phased array antenna to get the desired beam forming?
Well, nowadays I think most of the feeding is done through digitally. So because you don't want to lose too much of losses from the beamforming network, especially when you have a lot of elements. So currently what current technology is use digital beamformer. So that means we have LNAs. Say if it is receive phased array, you have LNAs for each element or each subarray. And then you have, then you convert them into A to D converter, analog to digital. And then all the beamforming, everything processing is done digitally. So that way you can generate any number of beams and any combination, or you can scan the beam, or you can shape the beam. So that is for digital processor. But if it is analog, I think there are ways of, for receive, I think it doesn't matter because you need the LNAs upfront. And then the different beamforming techniques could be waveguide technology, which is a bit heavy. So there is also Temline technology or Square X technology people call, which is a bit thin and lighter. And sometimes people, if you can afford the losses, have more amplification with the LNAs, then you can do printed technology as well. So it depends on bandwidth, it depends on other constraints. So you can do many different ways, the beamforming network.
So one last question, sir. How antenna radiation is affected due to high speed?
Due to what?
High speed from Amruta. Somebody called Amruta. She has given affected due to high speed. Is speed really involved?
Well, for the satellites, it's not involved because they're all stationary, and speed may be important for aircrafts because yeah, you can. But for antenna design, I think it doesn't matter. Signal processing wise, I think you see some differences. So antenna basically you design for a given gain and coverage requirements.
I think Karthikeyan sir is there. Karthikeyan sir, please go ahead. Karthikeyan sir, please unmute, sir. Please go ahead, sir.
There, yeah. He is not, I believe he is not connected with audio.
Yeah.
He's having some
Karthikeyan
audio
sir,
issue.
please unmute, sir.
I think he is not having any audio system. Your sound is having some issue. Please check your audio connection.
Yeah, now I think it's there.
No. Let to hear from you. Yeah. Hear me.
Now it's fine. Now it's fine. Now it's
Fine. Yes, there is a wonderful lecture. There is a specific.
No, we can't hear you, Karthikeyan.
Sir, you can use the chat box also, sir.
Yeah. I think we have some time, so we can fix up his audio problem.
You can go to another. If there are any other questions, we can go.
Yeah,
Sir,
I think
as
there
of
is.
now, no, sir.
Dr. Subhashi, do you have anything more? Or
No,
you
sir.
can,
No more questions, sir. No more questions, sir, from the audience. And there are a lot of praises. That's a wonderful session, sir.
So, yeah, I would like to thank Dr. Srivastava for chairing the session. And of course,
Thank you,
our
sir.
speaker, Dr. Rao, who is like, I would say that he's like a senior friend type of relation that we have. He guides us on many things. He's definitely a leader and legend. And one of the characteristics of the leaders and legends is they will never say that they are a leader or legend. So that is a hallmark of any L4 person. In the meantime, when I say these things, I request my volunteers to show some of the glimpses of Dr. Rao's journey, his early career journey. He was very humble. He sent some of his photographs that students will be displaying. And also, one of the feature of this type of talk, Meher, can you do that? What I said? Dr. Rao, you have to stop sharing your screen. Yeah. So, some of the points that he mentioned, his early career journey, players brought up from India, and then he has reached such a his career as technically as well as from the IEEE leaders and other fronts. He has initiated unique conferences in India also, and probably he might tell something that some new development is in the pipeline. So this is a great privilege for all of us, and also for the young students, young faculty members, some of my other young colleagues and students to hear him. And he has covered a nice coverage, azimuthal as well as probably elevation type of coverage. That means both technical as well as leadership. And in fact, he is a very nice human being also. I had the privilege to talk to him on several occasions, on several platforms in India and in abroad also. He drove us, I remember in one of the APS conferences, probably in 2017, from San Diego. He drove us to his house at LA, Los Angeles. And in general, what I want to mean is he's a very nice person. So now we'll have a little bit of informal session. So I hand over the podium to my volunteer, Grishma, to start the next part of the session. Yeah, Grishma.
Yes, sir. So now I request Dr. Devadi Ganguly, RMC Canada, to moderate the L4 series. Ma'am, please.
Good evening, everyone. Am I audible?
Yes, ma'am.
Yeah. And a very good morning to Professor Rao, Dr. Rao. And it was really a very informative session. And starting from your journey, the way you've shared your the journey details, it was a pleasure hearing you. And definitely the technical part was really amazing. And I have had the privilege of knowing Dr. Rao for a long time. And apart from being a very, very gentleman, he's a lovely host because I've been to his house, and he's a lovely host and a lovely person. And definitely, we have known each other for a long time. And I would like to ask Dr. Rao a very pertinent question in today's the present scenario. Like, sir, can you please? It's for the young generations who are pursuing research and who are about to start their research journey. Like, what is the importance of system level research in today's scenario? Because as we can see, like antennas or standalone antennas have been it's going to be saturated soon. So what is the impact of system level research, and how people should focus, the young researchers should focus on this part? If you can on this.
Yeah, that's a very good and a tough question, Debarati. So yeah, when I was doing PhD, I think I was really motivated to do work on GTD, geometrical theory of diffraction. So I know the applications because I worked in ECL before, so I know reflector antennas and how important it is. So some sort of knowledge is important. I think that you can get through getting some guidance from industry or working with industry. So that's the reason I sort of decided to join industry after master's, not doing directly PhD. So that gave me real understanding of requirements, what industry is looking, and also get the system knowledge a bit. So then when I joined IIT Madras, then I could immediately, my professor gave a paper of Professor Komjian and Pathak, hey, read this paper and see what you can do. So I took that paper, and for 3 months I didn't see him. So then he thought I left IIT Madras. So he asked one of the colleagues, hey, what happened to Sudhakar? I didn't see him for 3 months. No, sir, he's working in the library. So he Professor Narasimhan has an old cycle, Hercules cycle, and on the cycle he came very excited. He really wants to scold me or so he came with a lot of I can see his face. So he came to the library. I was sitting and then working on my research. He came, hey, what happened? You didn't see me for the last 3 months. Sir, I am working on my research. Then he said, what did you do? He never told me. I said, sir, then I gave him a bundle of papers, actually, which I was writing by hand. So I said, this is what I have done. And he said, okay, give me this, and can I take it and come back and look into tomorrow? So tomorrow come to my office at 8 o'clock. I said, okay, sir. I went there, and he said, this is amazing. I never saw my PhD student work so much. I think all this is worth about 4 to 5 papers. So can I write the papers? I said, sir, go ahead and write the papers. So I think that actually motivated me a lot is actually some of the papers, and the experience I gained from ECL was very important. And my PhD was also part-time PhD because I was a research associate under ISRO project. So, but part of my project actually I made into thesis as well. So I think it's important for if you're a young engineer or doing a PhD, I think it's very important. The time is precious. So my advice is don't waste time. So you work like I used to work 16 hours a day. So because those days the big IBM machines, I think they can take only big jobs only for 10 or so. So we used to go at 4 o'clock, submit the jobs, and then come back, and then have breakfast, sleep for a while, and then again go back to check the deck and see what we got. And that was daily routine. And most of the research we used to do in the nights. So you have to be motivated first, and you have to read a lot if you want to gain the system knowledge. I think you can't just work on a small project and do. You have to know where it goes and what is the implication. So I think knowing the industry helps a lot, and also reading a bit what others are doing and where your research is going. I think that's important. It could be a abstract research, but at the end, I think you have to know where your research is going. That way you can do better research and understand a bit better. So just focus on your research, don't waste your time, and you have plenty of time later to enjoy. So if you're doing research, I think just focus on the research, and it has to be one mission, that's all. Research, research, and research.
Thank you so much. And I had one more question. That is, nowadays, when you have there's a gap between academia and going into the industry. So young generations, they have this dilemma, like whether they should pursue into the academia, or whether they should. So you have any suggestions to them, like to have their focus on where they should go? They should know where to go. So any suggestions on that?
It depends on the person. I think it's if you are interested in the industry, I think PhD is not required, but I think it's preferred. So most of the companies actually view PhD as a higher degree, but it's just attitude is important, because passion for learning is important, whether you have PhD or not. I think we get a lot of PhD candidates here, but sometimes bachelor candidate is much better. He does much better work than PhD candidate. So it's all depends on the attitude of the person. So if you want to learn, there is always menu to learn, and you have to be self-motivated to learn and improve upon your knowledge. So that, of course, you have to work with a group. You have to need a mentor, and I think that actually helps a lot, I would say.
If we have time, I would just like to call a few of our people who, of our young, professionals who are working right now and very actively involved in research. So can I call Professor George Siddiqui if he has any questions, he'll be happy to ask. Sir, please.
Jawad shouldn't have any questions. He should have answers.
Yeah. Thank you so much. But I'm so, it was such a different kind of a lecture, like your whole journey, starting from your, village education to the, highest position here in Northrop Grumman and the Hughes and Boeing. That's such an inspirational journey. And I'm sure, those who are attending here would be inspired and motivated. And your stepwise journey and your inclination towards learning and your your outlook towards the research, and as you said that you've been maverick, right? That's the term you use for yourself for the whole journey. That passion must be there. And I'm sure this lecture would motivate all of us. It has also motivated me too. So I'm sure the younger lots who are attendees here would be motivated with this journey and take research seriously, and also look at the domain of the industry, and we as students, as from academia, so in the academia we always fight for research and paper publication, but then as Professor Rao said, the quality over quantity is what matters most. It might be just one or two or a couple of papers which could be a breakthrough, some pioneering work, or some really good research paper which will be followed by others. That's more important than breaking down one work into subsequent work so that we have many publications. That should be avoided. again, I think simulation, I've seen students doing simulation and just without understanding, especially the radiation patterns and the polarization of an antenna. That's so, so important. The concept, the conceptualization, the envisage, electromagnetic waves you have to really visualize until you visualize the electric fields and the magnetic fields and the duration of propagation, the whole wave, it's so difficult to understand. So getting a color plot is not that important than understanding what's happening, what's the structure, the propagation, and the current flowing of the structures. There is conducting material or a dielectric, which is basically acts as a scatter. So like everything is important, and like this kind of lecture from legends of the industry is such a it's so important than what we usually see from academians. And thank you so much. I don't have any questions as such, but the lecture was very impressive and very informative. Thank you so much, and thank you, Devarati, for inviting me.
Thank
Thank you,
you,
sir.
Professor Siddiqui, and you are the next speaker.
No doubt. Thank
Yeah.
you so much, sir.
Thank you.
I
Thank
would
you
now
so
thank
much.
you, sir.
Yeah, maybe you may request, Dr. Ganguly, you may request Professor Karthikeyan to have his comments. He's from IIT Tirupati.
So I would request Professor Karthikeyan to, we'd like to hear your valuable comments, sir. So would you please?
So can you please unmute, Professor Karthikeyan? Can you please unmute? You are muted. I see our friend Dr. Jogesh from Hyderabad.
Hi, Yogesh.
Sir, very good evening from India.
How are you doing?
You
How are
are
you,
on
sir? Nice to see you
Having
after a
good?
very long time.
comments.
Yeah.
And thank you, Dr. Chinmay, to call me in. In fact, I was
Yes,
had to be called.
nice to see you, even but virtually. We'll still wait for Professor Karthikeyan if he can settle his audio problem. Yeah, Dr. Jogesh, would you like to have some comment?
Yeah, sir, a very good walk through your journey of 45 years of career. And it has been very, very enlightening. And I think we'll learn a lot from you. We have so many things to learn from you. Probably through some reviews or through lectures or through interactions, directly one-to-one kind of interaction.
Yeah.
We'd like to have a continuous interaction with you for learning. Thank you very much, sir, for being with us for so long. Thank you.
Yeah. The beauty is this talk will be archived in YouTube, so it will be there for generations. Yeah.
Thank you very much.
Yeah. Over to moderator.
Yeah.
Learning.
I would like.
By the way, learning is mutual, Yogesh. I also learned from you guys.
Thank you, sir.
I would like to now invite Professor B.S. Manoj from IIST, if he's there, to kindly interact with.
Thank you, Devrati, for calling me out. It was a great opportunity to attend this event. As I was mentioning during my welcome lecture, that this is the treat of the year, we can say, or among all L4 lectures, this will be very, very different. In fact, I was mesmerized by the journey that Dr. Sudhakar Rao had taken. So much impressed, so much influenced by you. And I have been thinking that I'm a researcher, but I think your talk actually, make me rethink about what I have been doing and how to actually put in the effort that you have mentioned. So it's really, really impressive, and you have made me rethink about how to restructure my own research activities. Thank you so much for your wonderful description about your own journey. It made us really, really, yeah, aspire to become where close to your kind of stature in research. Thank you, sir.
Thank you, Professor Manoj. So my journey happened by accident. So that's all. Nothing planned. So it just happened, and I'm open to opportunities, and it came, and so it's sometimes I think happens by accident too. I didn't plan that, but happened that way.
Spectacular journey.
During my speech, I was actually hurrying because I didn't want a person like Dr. Rao waiting for my talk, whatever. So at that time, I probably forgot to mention, which I want to have on record now. Professor Manoj is also a brilliant organizer, a brilliant professor, a brilliant researcher. I am really fortunate to have a colleague like him in my department. And he is the, pioneer of IEEE activities in Indian Institute of Space Science and Technology. And currently he is the chairman of, EMBS chapter Kerala. And he was former chairman of, Computer Society chapter of Kerala. So,
Thank you,
I just want to mention to the podium, virtual podium, that Professor Manoj is a very accomplished, a very nice leader, and a very good researcher also. Thank you. I just wanted to have it here.
Thank you, sir. I would like to request Dr. Devdeep Sarkar from IIST Bangalore to have an interaction with Dr. Rao.
Yeah, hi, good morning, Dr. Rao. It was nice to hear you. I switched on and I attended your entire talk, and it was really motivating and for all of us, especially young early career researchers like us. So I will be asking I have a different question, because which we generally face from our students, and it's more related to the IEEE activities. So I mean, it would be great. I mean, you probably have done this in many forums, but it would be great that if you share or at least explain some of the benefits of becoming a IEEE FE Society member or student member, early career, whether that has any kind of impact in the future career. So if you share your thoughts, that is it.
Thanks, Devdeep. Yeah, that's a good question. I think, yeah, definitely. I think becoming IEEE member helps. So I was a member for almost 40 years now. So during early career, actually, it helps a lot, because you can interact with fellow IEEE members in the world. And when you go to the conferences, you can talk to them, and you can get the. And actually, if you have a question, actually, you can check with them and ask the question, email them, and they always ready to help. So I had a lot of questions, not when I was doing PhD, but when I was doing my postdoc. So I used to send an email to some authors of some papers. So they are kind enough to explain details, how they derived, and what are the implications. And some of them, I think I had a question about the validity of the equation. So some of them, they said, yeah, you're right, but certain cases this applies, but other cases it doesn't apply. So I think they become later your friends. You meet the same people in the conference, then suddenly they remember you, and then you get connected. So that helps a lot in your profession as well. If you're an IEEE member, student member now, so then don't discontinue your membership, because you need a continued membership. So if you're a member for 35 years, and if you're a fellow, then you become a life fellow. So basically your number of years as membership, and your age should be about 85, I believe. So when you reach that target, you become life fellow. So if you're a life fellow, then you don't need to pay membership again. So so when you become old, I think you become poor as well. So that helps. So when you go to conferences, you don't need to pay registration.
I don't agree on that.
No, because when you become old, all the money goes to your kids or the wife. So you don't have any money. So
Is it a side lobe?
it is back lobe actually. First and side lobe.
Yeah. Yeah. Well,
So actually you don't need to pay even IEEE registration fee for any conference. So there's some benefits becoming that, but more importantly, you can network with other bright people in the IEEE community. It always helps. So don't discontinue your membership. So
yeah.
it's not a significant money, but if you can afford, I think you should become a student member and continue as a member.
Mhm.
A lot of benefits.
So yeah, thanks a lot, and looking forward to. I mean, hopefully by WAMS, when WAMS is, I saw about the nice initiative where all of you are involved. So I look forward to attending that. I mean, hopefully next year by that time we have
Oh,
like that.
that's Professor Subhashini Ratna. I think she's the boss.
Yeah.
So.
Yeah, looking forward to see.
Thank you, sir. We will do our
Thank-
best, sir. Devdeep, sir.
Yeah, thank you, thank you. Looking forward to see you. Yeah.
Thank you, sir.
I have a question to Dr. Rao on the second part. What is your opinion? Like, let me tell you the background. Like, if I say in one sentence, the legacy of J.C. Bose is being carried forward. Like we have seen many Indian who have actively contributed in antenna propagation in technical fronts as well as leadership front. For example, starting from maybe Bharti Bhatt and some of the senior professors like Professor Garg, you mentioned Professor P.K. Shah, your own PhD supervisor, Professor Narasimha, and then next generations are also there and the young generations are also there. And we have seen people like you and then Professor Raj Mitra, Professor Tapun Sarkar, who are like Indian settled abroad, but they are very much technically and otherwise also very active in antenna propagation society. And I see the new generation, like for example, Professor Siddiqui is currently chairing the APS site. Dr. Devdeep is there in young professionals. There are a few more people from India. So my question to you is, what is the speciality and what is the connectivity that Indians have contributed in this particular arena? I believe we have contributed in other area also, but I see more contribution in the areas of antennas, propagation, electromagnetics. So what is your explanation on that?
Yeah, I think the Indian community is contributed quite a bit in terms of research in antennas and propagation. I don't know propagation much, but in antennas, I think there are a lot of people contributed. I think J.C. Bose, C.V. Raman, of course, they're working on high frequency stuff and spectroscopy, etc. But relevant to antenna, I think I would still say that Professor Narasimhan is one guy who is led everybody else. I think he whole Kharagpur together combined. I think he produced more papers and more researchers, quality researchers, not just researchers. Like Christopher is one example, and Ramanujam, Raghavan, and I think he produced about 12 PhDs or so. So they're all high quality PhDs, and they're all leading either in the industry or in the academia. BNR, same thing. He's a great teacher. I think I got most of my motivation from him. I would say that he's my mentor, and he's the reason why I'm here, where I am here. So he's continuously advising me throughout my career, and both at ACL, then LRDE, and then I was in constant touch with him. I think people used to get scared of him, but I was never scared. So, so maybe that's why he liked me. But I think people like that are very rare. I think both are unfortunately expired. Both Professor Narasimhan and Professor BNS. But there are other people as well. I think. I mean, to call them legends, I think I think you have to selectively. That's my opinion. I think it's other people think. But in terms of Indian contribution, definitely I think other people have contributed. Raj Mitra, Prabhakar Pathak, all others like Tapan Sarkar and who else?
I got your point. Thank you very much.
So yeah, it's I think legends. I think it's all depends on the person. I think whom he thinks is a legend. But for me, those are the people who are legends and leaders. So India has a lot of leaders too from industry like DRDO, ISRO, other places as well, radio astronomy. So there are good people. I think they contributed a lot. So that's why India is in the world map, and I think Indian scientists are well respected. So because we go through analysis, I think we have analytical mind compared to probably other people. So I think that helps a lot.
Yeah, thank you.
And your generation is coming up, so I think you're the future leaders and legends. I think you need to develop. So I think a lot of young faces I see today. So I think they're the future. So just work hard and not work hard, but work smart. I think that's important. At the same time, enjoy your work. I mean, don't just work. My sort of advice is get involved in other activities too, like sports or music, or you need something other than just to keep you, I think, all the way. I think 24 hours, if you think of work, it's not good. So I think you have to do other activities, get involved. So I think that helps a lot. So people who study 24 hours, I think I have seen that a lot of them, they didn't come up quite well. But people in the second, third ranks and working on other things like sports and maybe music, and I think that's they have come up.
It's very important. That is very important to switch on and switch off between your academics and other things. Yeah.
So my currently my rule is don't bring work to home, and don't bring home to work. So when you work, you don't waste time. You just work. If it is 8 hours, you work maybe 9 hours or 10 hours. When you come home, don't think of work. I just come empty-handed, and don't bother. I think you have to isolate. So sometimes that helps a lot.
Thank you.
Thank you so much, sir. Thank you so much, sir, for this lovely interaction session. So I would like to hand over now to Grishma to continue with further.
Thank you, Dabarati.
Thank you.
Yeah, maybe we can have a virtual photo session before we go to the next part. All of you may turn on your video. Our volunteers will take a snap. Oh, evaluation. Motion.
The future engineer.
Yes, she was very excited to be there on my
Hi.
show. So
Hi.
I'll ask you a question later on. Yeah, please go ahead with the next part.
So now I would like to invite Professor Anil Mohammed Sir, APC Chapter Advisor, Government Engineering College, Bartinel, for his comments.
Morning, Sudhakar Rao, sir, faculty members, academicians, industrialists, Good afternoon, good evening to all, and thank you, Chinmay sir, for because under your visionary, so many things happened, and I would like to share. Since that association started from 2015, the first talk we had was on antennas for 21st century payload applications, none other by our Sudhakar Rao sir, and that was the starting point when I got hooked that much with the APMTT societies. And regarding his talks, I was fortunate to interact with him many times, and through this IPMTT platforms, got lot of opportunities to interact with him, and very difficult to express in few words regarding sir's accomplishments. But I am very optimistic, like what other faculty or other people said just now, that I'm sure and optimistic that those who have listened to his words, especially the future generation of India, they will definitely, someone will come up to the level which to our expectations, and will make India next level as per the visionary of great Dr. APJ Abdul Kalam. And happy to get associated with Kerala chapter, and thanks to sir for accepting our invitation and having a talk. Back to Grishma for further proceedings.
Thank you, sir. So our session has almost come to an end. Now I kindly request Sri Arjun Mitra, ESSC and APA Secretary for the vote of thanks.
Good evening, all. Thank you for giving me this opportunity. First of all, I'd like to thank the L4 of the day, Dr. Sudhakar Rao, a true leader and legend indeed, for his informative, inspiring, and of course, motivating talk. And not only this talk, we have no words to express our gratitude for the way he has been supporting our activities for the last few years. Thank you, sir, on behalf of our whole chapter. Then I'd also like to thank the other dignitaries like Dr. Zhao, Dr. B.S. Manoj, Dr. Shubhashini, Dr. Sharkar, Dr. Ganguly, Dr. Siddiqui, and all others for sparing their precious time out of their busy schedule for this event. Thank you all. Then, of course, our leader, motivator, guide, and of course, without whose continuous efforts and vision, quality events like this was never possible, our very own Dr. Shaha, our MTTS Kerala Chair. Thank you, sir, for all your continuous guidance. And we are really looking forward to work with you in the future as well. Thank you, sir. These events actually requires a lot of efforts in the background, which was never possible without continuous and dedicated efforts of our volunteers. I thank Professor Anu Muhammad and his team from GEC Barton Hind, and also the other members from IIST Trivandrum for their continuous and dedicated efforts in organizing such events in a very flawless and beautiful manner. Then finally, of course, the participants. As we can see, we had more than 300 participants today. Thank you all for accepting this our invitation and all, and participating and all, and making the events like this a grand success. I will think that in future also we'll be keep on participating and following our chapters, and also, as already mentioned, all our videos and all will be available in our YouTube channel. So keep following our chapter activities. I thank once again all of you on behalf of MTTS Kerala. And finally, you know, this pandemic, COVID-19 pandemic is still going on. So I request all of you to stay safe, take care, and a very good night, all of you. Thank you.
Yeah, I would like to thank two, biggest support of our chapter, which is Professor Anu Muhammad and Sri Arijit Mitra, and student volunteers of Government Engineering College Barton Hill and IIST student branch. So to name a few like Meher, Malavika, Grishma, and then Elizabeth, Gopika, Vinod. So they are the real hero for our chapter and section to flourish. Thank you very much. Thank you very much, Dr. Rao and all the participants. Have a safe week, and hopefully we'll have a physical event again sometime, probably end of this year or next year. Grishma, you may conclude.
Okay, thank you, sir. So here we come to the end of the session. So once again, thanking everyone for the active participation, the speakers, the members, and all others who made this event a success. So before leaving, I would like to ensure that feedback form is provided in the link in the chat box. So participants, please, before leaving, please ensure that you fill it. So that's all from my part. Thank you and stay safe.
Thank you.
Thank you. Bye. Have a good day and good night to all. Thank you.
Thank you all. Thank you. Thank you so much.